Okay, hello guys. Whoa. There we go. It's me, Brandon Lee, and we're back with another video. Now, I don't know where to place my face. I guess I'll place it there. Alright, I'll be back. I need to check if my mic is working. Yeah. Okay, so it works. Okay, so we're back with a Khan Academy video. So let's resume. I don't even know what part we are on. So I'm just gonna continue, I guess. Lag. Okay. I'm totally. Oh wait. I'm doing some adjustments. Okay. Nah, I don't want to do it like that. Let's just do it normally.
We're told the double number line shows that 5 pounds of avocados cost $9. And so what is going on here with this number line? This shows how as we increase the number of avocados, how the cost increases. So for example, when we have 0 pounds of avocados, it costs us $0. When we have 5 pounds of avocados, it costs us $9. And so if you look at any point over here, let's say you look right over here, this would be, let's see, this is 1, right? This is 1, 2, 3, 4, 5. If you look at 1, this point on the cost number line would tell you how much 1 pound of avocado would cost. 2 pounds of avocados, how much would that cost? You would look at this second number line right over there. So they ask us, based on the ratio shown in the double number line, what is the cost for 1 pound of avocados? So
okay, so let's just pause the video and think about this laggy thing. I'll be right there. Just gotta take that out for a second. Clean that up. Okay, so let's see. Let's think about it. I think I'll quickly pause it to check my things, seeing if everything. Okay, so let's resume. So basically, you know what? I'm just gonna. I need to do this. No. Can I move you? I can still work. It works just a little bit. Okay, but anyways. What just happened?
pause the video.
Okay. So anyways, based on the ratio shown in the double number line, what is the cost of 1 pound of avocados? Okay, so basically what they're saying right now, 5 pounds of avocado costs $9. Okay? So what they're asking is, how much does one avocado cost? So that means if we divide by 5 here, we also have to divide by 5 here. So basically, big brain time. Okay. Let's start off by doing this. How many times does 5 go into 9? It goes in once. So 5 minus that is... Okay, so right now I will be thinking... okay, so... I'll be right back. Okay, so that takes out the 5. We get the 4. We get the 0. We bring down the 4. And then we have to put down the decimal point there. And we get the 8. I think. And that works. We get the 8 and we subtract by 40. Boom. So it's $1.80. Let's
Remember,
go.
1 pound of avocados on this top number line. We look at the second number line. The cost would be right over here. What is this going to be? Well, we could just set it up as a ratio. The ratio of pounds of avocados to cost is going to be, let me do this in some colors. So if I have 5 pounds of avocados, it is going to cost me $9. So the ratio of pounds to dollars is 5 to 9. So if I were to have 1 pound of avocado, I have divided by 5 to get 1 pound of avocado. I would have to do the same thing for the cost.
Yeah.
So if I divide 9 by 5, this is going to be 9/5 dollars of 9/5 dollars would be the cost of 1 pound. Well, 9/5 isn't always the most natural way to write money. So you could view this 9/5 is equal to 1 4/5, which is equal to 1 8/10, which is equal to 1.8, or you could say this is $1.80.
Why won't the...
If we were to go on to this double number line, the cost of 1 pound...
He broke the system. Damn it, why doesn't space not work?
avocado.
I'm spamming space.
Point right over here would be $1.80. You said 2 pounds of avocados. Well, now you would double it. So this would be $3.60. And you would go on and on and on all the way until you got to $9 here. Let's do another example. So here we are told the double number line shows how many model trains Irene can build in a week. So we can see in 0 weeks she can't build any trains, but in 1 week she can build 9 trains.
Yeah.
And they ask us which table represents the rate of Irene building model trains. So pause this video and see if you can figure it out.
Oh, flip. It doesn't work. A little bit of sneezies. Maybe this should work. Yeah, it's okay. Okay. Damn it. It's still like that. 50-50, I think. Yeet. Okay. So basically, the double number line shows how many model trains Irene can build in 1 week. Okay. Straightforward. Yeet. It's not moving. Damn it. That would not be helpful. Can you please move out the way? Thank you. Thank you so much. No. Perfect. I can leave you down there. Okay, so let me think about this question. So basically, there is a double number line. Straightforward. How much you can build in 1 week? So, which table represents the rate of Irene building model trains? So, for every question, I keep forgetting to say it, pause the video, so I'll just say it now. For every question there is, now and moving forth, just pause the video and try it yourself. But the double number line shows how many model trains Irene can build in 1 week. So basically, in 1 week, she can build 9 trains. So which one is correct? So what they're asking is, in 5 weeks, will she be able to build 45 trains? Let's check it out. Yes, for a matter of fact, you can. How about 12 trains? I'm gonna do some quick maths. It's 108 trains. That's correct. How about 26? Okay. 12 divided by 6. So 10 divided by 6 is 448. So that's a 1 and that's a 6. 1, 6, 4, 8, 8, 1, 8. That would be 18 for 2. So we have to double that up. So that is 216 plus 18. 216. 16 plus 18. Well, that is 34. And that's 234. Yes, it is. 234. Bang. Well, it's A, but I'll do B. Okay. No. You gotta be kidding me. Okay, so basically, B in 5 weeks, you can build 45 trains. So are you saying in 90 weeks, you only build 10? That's sad. I don't think I have to review that.
Once again, every week she can build 9 trains. So one way to think about it is the ratio of week to trains would be 1 to 9. So let's see, if I look at this table, I just want to see where the ratio between weeks to trains stays at 1 to 9. So 5 to 45, that is still 1 to 9. To go from 1 to 5, I've multiplied by 5.
Wait,
and then to go
I just noticed, I think for B,
40.
They switched it around. 10 goes on this side, 14 goes on this side, I think.
I've also multiplied by 5. So this one checks out. Now, and another way to think about it is 45 is 9 times 5. So 9 times.
That's big brain.
That might be an easier way to think about it.
That's big brain.
Over here, 12 to 108. Well, that's once again 12 times 9
is 108.
And then 26 to 234. Let's see, 26 times 10 would be 260 minus 26. Yeah, it would be 234. So this is 9 times. So in all of these cases, the ratio of trains or the ratio of weeks to trains is 1 to 9. So this one is looking good. So
but the next one is 9 to 1.
So let's just make sure that this one doesn't work. Well, over here, the ratio of weeks to trains is 9 to 1, not 1 to 9. The train should be 9 times the weeks, while here the weeks is 9 times the train. So just looking at that first one, we know that this is not going to work out. Let's do one last example. The double number line shows how many snowballs Jacob and his friends can make in 1 minute. In no minutes, they can make 0 snowballs. In 1 minute, they can make 12. Complete the table to show the same information as the double number line. So once again, pause this video and see if you can work this out.
Okay, funny. Right now, I have a friend named Jacob, and during recess I built snowballs, and it's snowing right now. Well, I actually don't know, but it was snowing today. Anyways, okay. So, like, in 1 minute, essentially it's 1 to 2. So it's M to S. Okay, so time in minutes. I'm not gonna do this good. Wait. Please no judging. Judging are for haters. Haters are for judging. I already messed that up. You saw nothing. No. You didn't see anything, obviously. So that's 1 to 12. 12 to 48 is times 4, so this is also times 4. And this is add up to get this, so same. Add up to get this. Big brain. So it's 1, 4, 16.
Well, we can think about it as a ratio. The ratio of minutes to snowballs. Is 1 to 12. So minutes to snowballs is 1 to 12. Or another way to think about it is the snowballs is going to be 12 times the minutes. And so over here, if I have 12 snowballs, well, we already know that's going to be 1 minute. If I have 48 snowballs, well, let's just think about it. To go from 12 to 48, you have to multiply by 4. So you have 4 times as many snowballs. It's going to take you 4 times as many minutes. And then if you go to 5, well, to go from 1 to 5, you multiply by 5. So you're going to have 5 times as many snowballs than you would be able to make in 1 minute. So 5 times 12 is 60. And we're done. It could be 1 to 12, 4 to 48, 5 to 60. For every 5 minutes, you can make 60 snowballs.
Woo! Give a shout out to Khan Academy. Okay, so let's continue. I think what I'll do is I'm gonna watch all the things, then I'll do maybe 1 or 2, then I'll end the video there. Get out of my face, sir. Evil. Okay. That's long. A ratio table gives a bunch of equivalent ratios. Let's look at an example where we build a ratio table. Ben drinks 1 glass of milk for every 2 cookies that he ate. I didn't pick up the middle finger. It's just that my finger got stuck. You didn't see anything. You didn't see nothing. We can use this ratio to begin a ratio table. A glass of milk to cookies, 1 to 2. If Ben drinks 2 glasses of milk, then he eats 4 cookies. So that's 1, 2, 4. Yeah, 2, 4, 6, 8. Yeah. Okay. These questions. Each question, solve it first. If you don't solve it first, you go to jail. No, you don't. Okay, this time I'm gonna do it so well. You're gonna be so surprised. Try hard mode. No, nothing to see. See, I wrote straw so good. I'm not struggling. I'm just faking. Yeah. See? Do you know how smooth that was? I got this. I caught a Pikachu. Yes! Finally! That took forever. So right now we can see the ratio. Damn it. Right now you can see the ratio, okay, is 28 to 4. But you know, we can go down to 1. What's 4 divided by 4 is 1. So 28 divided by 4. Quick maths. 7. 7! I hope that wasn't too loud. If it was, sorry. Okay, so basically it's 7 to 1. So there's 3 right here. So we plug in the 3 times 3, 21. Perfecto. Then that's 70. So times 10 here. Perfect. I know, right? I'm perfect. So that's 10, and that is 21. Thank you for my service. That's so good. I didn't hear. Okay. Luigi! Let's go! Green for the win! Luigi uses 39 cups of flour for every 6 pizzas he makes. Okay, that's a bit too much, is it not? Okay, so I can't do it. Flour. I love flowers. They smell great. That's perfect. Perfect. No! Stop. What am I doing? Yay. Finally. That took like 30 seconds. I got the touch. It's 39 to 6, right? What can we do? What do we see in common? We see they're both divisible by... I can't hear. If you said 6, too bad. You are wrong. So we can divide by 3 on both sides. So let's do that. 6 divided by 3? 2. Why? Oh. 39 divided by 3? 13. Nice. You guys are big brains. So it's 1. Oh no, we can't do that actually. So the pizza side, you can only make an even number of pizzas. Oh well. Oh, 13. Oh, I scored a point. A bang. No, why did I do that? I'm so dumb. Anyways, okay, so 4 we can just multiply by 2, multiply by 2. Quick maths. 13 times 2, 26 plus 1 minus 1. It's still 26. So I was correct after all. Yeet, yeet, yeet. Let's go. 20 is gonna do. Yes! We're so good. High five. Nice. High five. Reload, early up. Okay, perfect. You need 3 sticks of butter. So 3 sticks of butter, and you make 24 cookies. That's actually kind of a lot. So, I'm too lazy. SOB. This side is sobbing, and this side is knock. The knockless monster. The notchless monster. Look out for the notchless, noseless. Look out for the noseless monster. Okay, I think I'm perfect. Yeah, I told you I'm perfect. Yeet. Okay, so basically it's 3 to 24. What's in common? They're both divisible by 3. Correct, you you guys are so smart, big brains. The 3 divided by 3 is 1. 24 divided by 3, what is it? If you said 8, you are correct. So there's 16 on this side, so let's multiply by 2 and we get 2. Perfect. 5 on this side, we can add these 2 to get this one. I love this rainbow, I'm so good. Watch this. Yeet. That one kind of messed up. Nothing happened. Wait, let me double check this. Oh yeah, it's correct. I thought I was wrong because I'm not good at quick maths. Perfect! If I get this wrong, I'll dab. Okay. Olivia needs 32. Oh wait, what am I doing? And a half licks? Eh? Oh well. For every 3 lollipops she eats, number of licks. That's kind of weird. Oh, okay. Okay. We got this. We got this. Ow, my eye hurts. I'll be back. I need some eye drop. There's something in my eye. No, I messed up. Okay, I'm back. To 32. It's kind of weird that you say licks. Oh well. So 6, that is, quick maths. Half plus half equals a 1, so 32 to 65. 12, oh, we multiply by 2. 60 times 2 is 120. 5 times 2 is 10. 120 plus 10 is 130. That was the best rapping I could do. Yeah. If I get this wrong, I have to check again. Oh, I knew that.
We're told this table shows equivalent ratios to 24 to 40. Fill in the missing values. And they write the ratio 24 to 40 right over here. 24, when the numerator is 24, the denominator is 40. So in that way you can think of 24 over 40. But then they want us to write equivalent ratios where we have to fill in different blanks over here in the denominator and here in the numerator.
That's what we've
There's
been
a bunch
doing.
of ways that we could actually tackle this, but maybe the easiest is to start with the ratio that they gave us, where they gave us both the numerator and the denominator, and then move from there. So for example, if we look at this one right over here, the numerator is 12. It is half of the 24. So the denominator is also going to be...
Okay, stop right there. Stop. Wait a minute. Okay, so moving on. So right now, they said that we have the equivalent fractions of 24 to 40. Well, 12 is half of 24. So that means the denominator is also half of 40. So that's a 20. And that gives us a score right there. Home run! Next one. 12 to 3, that's divided by 4. So 20 should also be divided by 4. 20 divided by 4 is 5. Good job. You guys are smart. 40 is half of 80, so what do we do next? That means the numerator is half of the next numerator, so it should be multiple of 2. So times 2. What's 24 times 2? If you said 49, you are wrong, because it's 49 minus 1, which is 48. It's 5, 20, 48.
Of the denominator here, it's going to be half of 40. So we could stick a 20 right over there. And then we could go up here. If you compare the 3 to the 12, to go from 12 to 3, you have to divide by 4. So in the numerator, you're dividing by 4. So the denominator, you also want to divide by 4. So 20 divided by 4 is 5.
This guy's smart.
And then we have one more to fill in, this numerator right over here. And we see from the denominator, we doubled the denominator. We went from 40 to 80. So we would double the numerator as well.
Whoa!
So we would get 48. And what we just did here is we wrote 4 equivalent ratios. The ratio 3 to 5, or 3 over 5, is the same thing as 12 to 20.
Remember I said that they are kind of like fractions? Oh, look at this. Boom! Hat. That's how you make division easier. So like if you see division questions, think of this first. Think of fractions. Okay. Fractions. Oh yeah, I also had a new haircut, but that's not relevant of what we're talking about. Fractions. Let's say 1,000 divided by a million. Well, we can divide by 1,000, so it's just 1 divided by 1,000. So that's what you do. When you think ratios, think fractions.
It's the same thing as 24 to 40.
I mean,
it's the same thing
when
as
you see ratios, think fractions.
8 to 80.
Yeah, that sounds right.
Let's make sure we got the right answer. Let's do a couple more of these.
Wow, he's so smart.
The following table shows equivalent fractions to 27/75ths. So then they wrote all of the different equivalent fractions.
Okay.
This table shows ratios equivalent to 18/55ths. Fair enough. All right, so these are all equivalent to 27/75ths. These are all equivalent to 18/55ths, so all of these. Which
fraction is greater? So, which is greater? Trying to snipe this down. Okay. It's fair enough. Okay, so we'll write down this side. No, that I shouldn't do that. Wait, I need to do some big brain thinking right now. How would I approach this problem? Okay. Well, I don't know how you guys would have done it, but what's this? I found a heart. Yay! Okay. I don't know how you guys would have done it, but yeah, this is how I would have done it. So like, I see they're both divisible. This one caught me. Damn it! I was that close. How will I do this? Well, I know what to do, but okay. I'll just try to simplify it as best that I can. So basically what I would do is simplify it. So 27 divided by 3, 9 over 25. Or, how would we simplify? I think that's simplest form. 1, 2, 3, 4, no, 5, 6, 5, but yeah. So I think that's already simplest form. And then, what I would say next is, this one caught me out of my air. How do I explain this? What should I say? Okay, so let's just get the, oh yeah, I see it. So get the numerator the same, okay? So all you have to say is, which one's bigger now? 18 over 25 or 18 over 55. The thing with fractions is if the numerators are the same but the denominator is different, the smaller one is bigger. So I would say this is way bigger than that.
Is greater, 27 75ths or 18 55ths. So this is an interesting thing. What we want to do, because you look at these two things and you're like, well, I don't know, their denominators are different. How do I compare them? And the best way that I can think of comparing them is look at a point where you're getting an equivalent fraction, and either the numerators are going to be the same or the denominators are going to be.
Yeah, that's that.
So let's see if there's any situation here. So you have the situation where we see 27 over 75 is 54.
Well, you can get the numerator the same. It's just that on this it doesn't show because you can go down if you think about
150. And over here we see that 1855
so I think it's,
is 54, this 54 jumped out at me because it's the same numerator, over 165. And that makes the comparison much easier. What is smaller,
I didn't see that.
54 over 150 or 54 over 165? Well, if you have the same numerator, having a larger denominator will make the number smaller. So 54 over 165 is smaller than 54 over 150, which tells us that 18 over 55 is smaller than 27 over 75. So let's see which of these. So this is saying that 27 over 75 is greater than 18 55ths, and that is absolutely right. Let's do one more of these.
All right.
Lunara's friends are running a race. Each of them runs at a constant speed, starting at time 0. Which of these tables might show the distances one of Lunara's friends traveled over time? So they're running a race. Each of them runs at a constant speed, starting at time 0. So table
oh
1.
My God!
So distance run in meters.
Oh,
so they're running at a
okay. So Lunara's friends are running a race. Each of them runs at a constant speed. Table 1. 3 meters to 2. That's what I'll write. The next one says 11 to 4. And the last one says 1 to 1. Pop them.
So table 1.
Okay, which of these tables might show the distance? Oh my God. Okay. Might show the distance.
So distance run starting.
I can't see.
They're running at a constant speed. So the ratio between distance and time should be constant throughout all of these possible tables. So here you have a ratio of 3 to 2. If you triple the distance, we're tripling the time. If you multiply the distance by 5, we're multiplying the time by 5. So table 1 seems completely reasonable. Let's keep going. Table 2, 11 to 4. And
oh my God, there's 4. You gotta be kidding me. Okay. All I can say, get out of here. That's all I'm saying. That is so wrong. Okay, so let's see the first one. So 3 times 3 on the bottom. Okay, it works. How do you get the 15? 12, 15. Okay, so you do 6. So double that. 12, and then I feel like the answer is the first one because there's only one answer. But let's just check all of them out. The third one. Okay, the third one is so wrong. It should be 1 to 1, so they should all be the same. Oh, you get it? You get it, third? You get it, my guy? You get it, my guy?
12 to 5. Here it's just incrementing by 1, but the ratios are not the same. 11 to 4 is not the same thing as 12 to 5. So we're not going to be able to, this is not a legitimate, this right over here is not a legitimate table.
Computer.
Table 3. So 1 to...
Pause it. Okay. 14 to 10. Okay, sounds reasonable. Next one. Oh, the next one works. Wait, whoa. Stop right there. Check out the last one. So that's 7 to 5. I'm just writing it down for the last one. Okay. Let me check this out. So times 2, 42. Oh, it works? I thought there was only one answer. Okay.
Then when you double the distance, we double the time. When you triple the distance, from 1, you didn't triple the time. So table 3 doesn't seem to make sense either. Table 4. So 14 to 10. So that's the same thing as, let's see, that's the same ratio as
5.
If we were to divide by 2 as 7 to 5 ratio. If we divide both of these by 3, this is also a 7 to 5 ratio. And if you divide both of these by 7, this is also a 7 to 5 ratio. So table 4 seems like a completely reasonable, scenario. And we can check our answer, and it is. We're told this table shows...
this thing just restarted somehow. Okay, my guy, this is my last one.
We're told Kenzie makes quilts with some blue squares and some green squares. The ratio of blue squares to green squares is shown in the diagram. The table shows the number of blue squares and the number of green squares that Kenzie will make on 2 of her quilts. All right, this is the table they're talking about. Based on the ratio, complete the missing values in the table. So why don't you pause this video and see if you can figure it out. Well, first let's think about the ratio of blue to...
Okay. So the table says about the okay, get the blue. Yeah, so right now let's count. Right now it's 3 to how many? 5. Right now it's on to a 3 to 5 scale. Okay? But then it says 21 to whatever, and this time whatever to 20. So let's first of all, let's times by 5. Times by 5, 15. Wait. Okay, and let's check out the next one. Times 7 times 7, 35. It's 35 and 15.
Squares. So for every 3 blue squares, maybe that same or similar color, for every 3 blue squares, we are going to have 1, 2, 3, 4, 5 green squares. So the ratio of blue to green is 3 to 5. And so in quilt A, she has 21 blue squares. So she has 21 blue squares. How many green squares would she have? Well, to go from 3 to 21, you have to multiply by 7. And so you would take 5 and then multiply that by 7.
30.
So you'd multiply 5 times 7 to get to 35. As long as you multiply both of these by the same number or divide them by the same number, you're going to get an equivalent ratio. So 21 to 35 is the same thing as 3 to 5. Now we have a situation in Quilt B. They've given us the number of green squares, so that's 20. Well, how do we get 20 from 5? Well, we would
4.
multiply by 4. So if you multiply the number of green squares by 4, then you would do the same thing for the number of blue squares. 3 times 4 is going to be equal to 12. 12 blue squares for every 20 green squares is the same ratio as 3 blue squares for every 5 green squares. Let's do another example. Here we are told the following diagram describes the number of cups of blue and red paint in a mixture.
Let's just get ready to...
What is the ratio of blue paint to red paint in the mixture? So try to work it out.
Okay, I'll quickly pause the video. So where were we? 99%, so satisfying. Okay, so right now, okay, count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, that's a lot. Oopsies. 10 to what? Damn it, I messed up. 2, 4, 6. Okay, 6. What is a ratio of blue paint to red paint in the mixture? So we can obviously make this go down. Let's make it go down by half first. 5 to what? 3. Can we go any further? No. Unfortunately.
All right, so let's just see. We have 1, 2, 3, 4, 5, 6,
Okay.
8, 9, 10. 10 cups of blue paint for every 1, 2, 3, 4, 5, 6 cups of red paint. So this would be a legitimate ratio. A ratio of 10 cups of blue paint for every 6 cups of red paint. But this isn't in, I guess you could say, lowest terms or most simplified terms, because we can actually divide both of these numbers by 2. So if you divide 10 by 2, you get 5. I'll do that in blue color. And if you divide 6 by 2, you get 3.
3.
So one way to think about it is for every 5 blue squares, you have 3 red squares in this diagram, in this tape diagram that's sometimes called. Or you could say for every 5 cups of blue paint, you have 3 cups of red paint in our mixture. And you can even see that here. So 3 cups of red paint and 1, 2, 3, 4, 5. And 5 cups of blue paint. And you see that again right over here. Let's do another example.
Okay.
Here we're told Luna and Ginny each cast magic spells. The ratio of spells Luna casts to spells Ginny casts is represented in this tape diagram. All right. Based on the ratio, what is the number of spells Ginny casts when Luna casts 20 spells?
Okay, stop. Wait a minute. So clearly Luna spells 4. 2, 4, 5. 5. No! That looks ugly. But still, green is the best color. Get green shirts. Hashtag Brandon Lee. Hashtag Team Trees. Yeah, hashtag Team Trees. I'll try to say that. So what if Luna cast 20? Be careful of the wording because they can both get to 20, remember. Well, that's a better orange. To what? So that's times 5. So times 5, 25. So that is 25.
Pause this video, see if you can work it out. All right, so let's just see the ratio here. For every 1, 2, 3, 4 spells that Luna casts, Ginny casts
5.
1, 2, 3, 4, 5 spells. So the ratio is 4 to 5. But if Luna casts 20 spells, Well, to go from 4 to 20, we had to multiply by 5. And so we would do the same thing with the number of spells Ginny casts. You'd multiply that by 5, so it's 25. So 4 Luna spells for every 5 Ginny spells is the same thing as 20 Luna spells for every 25 Ginny spells. And so how many spells does Ginny cast when Luna casts 20 spells?
25.
She casts 25, and we're done.
Okay, I guess that ends my video. Peace out.